Welcome back, y'all. In this video, we're going to keep going with our reminder of some of the algebra that might be long gone by now. Specifically, let's go ahead and read the entire problem in front of us. Factor completely using the factor by grouping technique. And specifically, we're looking at x squared minus 2x plus 4x minus 8. Remember that, I guess we got to do a quick remembering. Anytime we're looking at math, one of the first things I want to say is that the least important thing from the standpoint of learning is the answer, meaning to say that if we understand what we're doing and we kind of encoded the ideas, we'll get to the answer eventually, right? The important thing is when we're learning to really expand on the ideas and encode mathematics in our brain. And to do that, I like to use Joe Bowler's ideas of multiple representation. I see this in a little bit of different things. I call this Van Viz. Let's see if we can describe things verbally using abuelita language that would make our grandmothers happy. Also nerdy language. So if we got in a street fight with a mathematician, we could bring out some real big shields to protect ourselves, which is nerdy language. We also have what we call visual representations, and then interest and intrigue. Can we ask questions? Can we really get curious about it? The further we get into it, the easier that is usually. And then also, can we write down our ideas that come up from these ones in symbols? So can we actually write those on the page? So in this case, I just want to do a quick recall. What does it mean to factor? So I'm already intrigued. I see a word that kind of slaps me in the face. Factor completely. What the heck does it mean to factor? So the first thing I'm going to do is kind of ask myself that question and see if I can do a quick recall. So if we were in class together, I would ask you all, what do you remember about factoring? So factors are part of multiplication problems. To factor means to break a product into parts. One of the really exciting things that professional mathematicians do all the time is generate examples. I'm going to use the number 8 because it reminds me of my older brother. He's a stud soccer player and he used to wear the number 8. So if I want to factor 8, what I would do is break it into its component parts. So 8 is 2 times 4. And then I know that 4 is 2 times 2. All of a sudden, I've broken 8 into its individual factors. I've factored 8. Similarly, we could have, if you take a look at this, we could have looked at 4 plus 4. Notice if we think about this as a group of additions, that's going to be 4 outside of 1 plus 1. In other words, this is kind of like the opposite of distributivity. Instead of passing the 4s out, we're kind of taking the 4s away. So 4 plus 4, if I look what's common in those two factors, well, it must be there's a 4 in that factor and there's a 4 in that factor. So 4 times 1 plus 1, I'm undoing distributivity. It's kind of a recall from a previous life. Here's a claim: factor by grouping we look for common factors in groups of two. So specifically, x squared minus 2x plus 4x minus 8. We'll talk, factor by grouping comes in when we're trying to factor quadratic polynomials. We're going to call this thing right there group 1. We're going to call this thing right there group 2. So now I would ask you at home, do you see anything that's common between x squared and negative 2x? Is there anything that you could factor out, like we factor out this 4 over here, between those two things? And maybe if you're looking carefully, you see there's an 2x's here, x times x, and then there's minus 2x. What if we were to take out an x there? What would be left over? Well, if I take out an x from x squared, I have an x left over. If I take an x from negative 2x, I have a negative 2 left over. So if I factor group 1, I can take an x out and I'm left over with x minus 2. What about group 2? Do you see anything that's common in the first summand versus the second one? Those two, I see a 4 here and an 8 there. What if I were to try to pull out a positive 4? What's 4? If I take out 4 from 4x, there's an x left over. If I take out 4 from negative 8, there's a minus 2 left over. So all of a sudden, I've taken out an x from the first group and a positive 4. I got to make sure to write that I'm taking out a positive 4 from the second group. And check this out. Now I have this single chunk that is identical in both terms. So specifically, we could undo distributivity. Instead of going the forward direction, let's go the backward direction. Let's pull out the x minus 2. That's the chunk that shows up in both of them. And then notice here I've got an x, and here I've got a plus 4. Here I've got x plus 4. And that's exactly what right distributivity would have us do, right? Right distributivity says that if you have a chunk on the right that shows up in both factors and it's identical, and all of a sudden we're going the opposite direction, you could pull that chunk out and then add or subtract the individual pieces that are associated with that. Well, here's my chunk, here's my c. I have c times x plus b times c. So a times c plus b times c must be a plus b times c. A times c plus b times c is a plus b times c. So factor by grouping is kind of a creative way to undo multiplication that we've done with distributivity by kind of chunking the information into two groups, right? And we'll see that this comes in handy in just a little bit when we're trying to factor up what we call a trinomial, a quadratic trinomial, which is a major theme in this algebra class when we're trying to undo forward operations by going backwards. All right, nice work, y'all. See you in the next one.